Right, we should be live. So welcome. This time it's also gonna be fun. Last time what we did, we've built an NFT and listed on OpenSea. This time we're gonna build an NFT and list it on OpenSea. No, but really, we're gonna kind of build on top of the last stuff that we've done. Because what we done last time, we built an NFT, listed on OpenSea, but we haven't got into the metadata part of it, which includes the actual image that you see on the NFT, which is kind of important. So we're gonna talk a little bit, and I'm gonna demo how you can do that part, and also I'm gonna talk a little bit about how to do the generative art side of things. I mean, people are making fun of me, of my skills of design, so it's not gonna be good. but yeah, we can at least try to do the coding part of it. All right, so let's start there. Actually, let's start with the images. So what do I mean by generative art? If we go to OpenSea again, boom. Last time we looked at some of these crypto bastards, I think. No, something else. Huh. Okay, well, I think last time we looked at something like this. No, that's probably not in. Let's try to find version 1 of this thing. Cool. So that's probably it. What I mean by generative art, like if you look at these images, they all kind of follow the same, the same kind of visual, and then they have a different hats or different accessory or different mouth or different eyes. And that's how you like generate loads of them. You do like few iterations of each item, like let's say the skin color, and you do few heads, and then you run it through some algorithm where you just combine all the combinations, and then you get loads, 10,000s of these guys. So let me show like simpler example maybe, which anybody could do. I've done that yesterday. So this is GIMP. It's, if you're using Photoshop, then that's very similar. So Photoshop is for people with money and GIMP is for the rest. Well, in reality, it's, GIMP is, you can also rephrase it in a way that GIMP is open source, so you're supporting the open source community, not open source. So anyway, this is GIMP. And how you do this is that you have layers. That's the key thing to it. You have layers, and if you look here on the right, oh, you don't see it because it's my face in there. Here, there's a layers section right here, and these layers they are stuck on top of each other. So it goes from bottom to up, and then they're going to be applied on top of each other, as we're going to see. So what you would do, you would do like a basic shape. In my case, it's the body, right? Looks like this. And then you can add few backgrounds, maybe, right? And then you can add like a skin color. And then you can have multiple skin colors. And then maybe you want some accessory as well, right? And that's basically it. If you want to, build as many as possible, you would just export these layers as separate images, and then have a script combine them. For our purpose, we're just gonna export few of these images. So we have, I don't know, maybe 3 or 4, so we can play with this. Let's deploy it to downloads, probably. So you're just gonna export them here with few numbers, like 0, 1, 2, 3, maybe. So we're gonna export this version, and then maybe with body but without background, with different skin color, without the glasses. No. What did I do? And then this one will be 0, 1, or just 1, I guess. And then maybe let's do this guy with the slash, and maybe red background. And we can do number 2. And then I think we haven't used this, which is nicer without background, I think. And we can do number 4. So we have 4 of them. Yep. Cool. So now when we build our art, so we can move on. So let me just discard changes here. And then if we look into, if we look what we got these 4 awesome images, which is going to be our NFT image. So that's basically how you do the generative art part. So that's that. Let's now see how you can connect these images to the NFTs that we've built last time. If we look at this example, right, there are such a thing called metadata about NFTs, which is where all these data is stored. Now we're going to look at example how it looks like for this specific collection or this NFT. So as we looked last time, if you look details, you can see the contract address, which is the smart contract holding the actual NFTs, like who owns which NFT. If you look at that, and wait a little bit. So this is a contract. If we look at contract like last time we did, you can see the source code of it, which is pretty neat. And that's because it's verified, meaning the author of the code uploaded the original source code there as well, which gives several advantages, including that you can go and see what the source code was here, but also you can interact with it. So you can do, there's a read and write contract. Read contract just means view and pure functions that don't create any mutations on the blockchain state. You can call them without being logged in or without using your own wallet. It's just public information. You can run it without spending gas, basically. And there's this, there's owner of, what's the one we looked at? We looked at, 7434 is the ID of this token. So if we query this and wait again, we get the wallet address that owns this specific token. What you can also do, which is important for us, is this token URI, which is Universal Resource Identifier, I think. And it's basically like a URL, meaning link, like the thing in a browser here, where you can fetch more information about this token, which is not on the blockchain. And again, you just put in the token ID here, and then you get some result back. We got this URL, right? And if we follow this URL in our browser here, we got some JSON. So this is a JSON format, which is a JavaScript native, but it's also everywhere else. Format of data, like how you send it. If we open it in new file, so we can not this, so we can read it nicer. So I'm going to copy this and then paste it here, and then I'm going to select the mode to be JSON, and then I'm going to say format, please. It's going to format it for us, and here we see what the metadata contains. So it contains token ID, then there are some name and description. It's usually like there are some standards, we can get to it, but it's Wild West. You can put whatever you want there. And then there is the image one, which is again another link. And if we take this link and open that in browser, we're gonna get the image. So that's how OpenSea fetches this image. Also notice that there's this property sections, right? Like bad habit pipe, for example. If we look back at what we got here, there's a attribute section, and there should be here bad habits pipe. So that's where OpenSea gets this information from. It's all coming from this metadata. One distinction that I want to make at this point is that this is so-called off-chain metadata, meaning it's not stored in the blockchain itself. So this is on Ethereum, I think. It's not stored on the Ethereum blockchain, right? The only thing that's stored on the Ethereum blockchain is the URL, how to get to the metadata. So when we've done this call here again, how did we get here? We went to OpenSea, we went to details, and then we went on Etherscan to see this contract. Then we went contract and then read contract. Now we are interacting with the contract. Now we are interacting with the actual, blockchain stuff that is stored on blockchain. And if we call this token URL, I forgot the ID, but I assume they have a token 123 as well. It generates or it stores in some way this URL. This is what we're gonna figure out next. Like, how do you store this, right? And again, you can just use that, and boom, you've got it. One more thing I wanted to mention here is that the ability for us to call these read contract, write contract is because the owner or the author of the smart contract verified their contract. So then you can interact with it on Etherscan. But sometimes, like when you look at, I don't know, my friend has a Moto Universe NFT, I think, yep. And if you look at his smart contract, you see it's not verified, and you just see this, and you don't have an option to like query it or something. And it's following a little bit different standard, so it's not like perfect example, but it's, this could happen on any standard. While when we looked at these bastard punks, I don't know if it says here. Oh, here it is. It's the token standard ERC721, which is the one we used last time as well. But I wanted to show you one more thing. So this is just a standard, right? So any token that implements this ERC721 token should be able to give you back the metadata for you. So that also means that you already know the interface, even if you don't know the actual implementation, how to interact with it. So that means that we can interact with it from the code as well, from our laptop. So let's do that, just to demonstrate that you would get the same data, even different ways. So also our Beaver NFT that we did last time happens to be ERC721. So that's kind of interesting, right? So what we're gonna do next is we're gonna truffle console to the Ethereum blockchain, to the mainnet, to the primary blockchain, and then we're gonna interact with this crypto bastards NFT directly. So that's gonna be kind of fun. Okay, so what do we need for that? We need, look in the truffle config. We currently have just one net fork, which is this ring capitas net fork. So we need one more because we need to be able to connect to the production one. Let's just call it ETH. Private keys doesn't matter because we're just going to be using the same thing. But for the URL, we need a different one. So how do you get a different URL? So what we did last time is that we went to Infura. Infura is a service that has nodes connected to each network, and that lets you kind of connect to these nodes and interact with these blockchains from anywhere. So I don't have to run Node on my laptop on my own computer, but I can just use theirs. I'm just gonna fetch the password. Boom. Nice. And then this is the URL you want. So you take this mainnet thing, and you're good to go. Now, if you remember correctly, last time what I've done is I used the secrets file where I have my private key and stuff. So I'm just gonna, switch scenes while I'm fixing this, so you don't actually see my secrets. But that's exactly what you would do. You would use this URL, put it there, and then I created a new key here that you're gonna see in a minute. So now we still have a private keys, Infura URL, and the new thing I added is Infura URL, which is the mainnet network. And then here for the ETH, we're gonna use that one. And the network ID for the production is 1. With that, we should be able to just connect. Network ETH, boom. Cool, we're connected. And now this is a little bit hacky, but that's what we're gonna do next. Is we know, this is the Buster Gang Punks, whatever. This is the contract, ERC721. So we know the address of this contract. We're gonna copy that, and then we don't know the implementation, like we could find out, but let's say we don't know the implementation, but we know it's using the ERC721 interface. And we also know that our token is also using ERC721. So what would happen if we would say that on that address that I just copied, it's not the, let's imagine that it's not the punks, but it's our NFT instead. If we send, functions or calls to what we know exists on our contract, they're gonna work as well because they're implementing the same interface. Like this is a little bit sketchy because you could just cast them to ERC721, but then you don't get auto completion here. So that's just why I'm doing this complicated stuff. So let's just call it punks, and I'm gonna say. So what I'm doing here is get me an instance of Beaver NFT at this address. But at this address, there isn't Beaver NFT deployed. What there is the CryptoPunks. But it has the same interface, so we can use this. Right? So we can do punks total supply, probably. And it returns some number. What we can also do is if we look back here, what was the 7434, whatever. We can say punks token URI, and then the ID of the token we're interested in, and we get the same address that you can go to. And then if I copy this and open in a browser, it's exactly the same URL here, right? So I wanted to show you that you can do that as well. That's good. Perfect. So let's talk more about this, JSON. what does it actually have in it? And is it standardized? This is more important question. Is it standardized? And the answer is yes, it's standardized. That's the reason why if we look at OpenSea, they can show these details for different NFTs, even if OpenSea doesn't know about the existence of these NFTs in advance. So you can look at OpenSea metadata standard. They have a pretty good page describing how this works. So you can read through this, but the bottom line is that the ERC721, if you remember last time, the NFT, to build an NFT, you need to adhere to one of two standards, which is this ERC721 or ERC1155. The bottom line is that ERC721 itself, it doesn't specify the metadata itself, not the structure, not how you're supposed to do this. ERC1155 does that, but for ERC721 there's such called an extension. So there are extended standard that you can use if you want to support metadata and images on NFT, which we do. So that's how it works. And then the metadata structure is defined in that extension to that standard. So you want to adhere to that so that all the marketplaces know how to interact with you. So that's what I wanted to say. If we look at our code again, what we've done, we implemented this ERC721, right? But if we double click on it and look, that ERC721 is implementing this interface, but it's also implementing this. This is the extension interface. So this extension interface has the token URI method that we were calling on those CryptoPunks, if that makes sense. So that's where we get this this function from. And then if you look left here, this is what we got from null modules OpenZeppelin. When we installed OpenZeppelin, we got the contract itself and also these extensions that are pretty interesting. So metadata, enumerables. Enumerable is very good if you care and you want to list somewhere, per the owner, per wallet address, what tokens it owns, because by default you don't get that. Pausable, so you can, as an owner, you can pause minting and transferring of tokens. That's mostly security stuff. If your contract gets compromised in any way, you can always pause it. So that's nice, and so on. But for us, the metadata is important. But also, as we saw, the default ERC721 that we're using already includes this. And if we find the token URI, it's already implemented here. It's using some sort of base URL. If it's not supplied, it's going to return empty string. Otherwise, it's going to do this, which we're going to talk about in a minute, but it's going to concatenate the base URI with the token ID. Perfect. So we have that. Let's do one more thing. So now, if we do just truffle deploy, truffle develop, boom, and we're gonna go back to our Beaver NFT. So we have pretty much vanilla ERC721 implementation. We just added the mint function, or exposed it rather. What we can do, we can say Beaver NFT. Let's do this instead. And then we can say deployed. Boom. And then we can say total supply. It should be probably, oops. Oh. Huh, maybe we didn't deploy it. Let's deploy it. Okay, we can do this. Oh, I think I know why. So our standard, it doesn't actually have the total supply method. It just has this total supply attribute. And I think you call it a little bit differently. Let's see. So this, no, it worked. Okay. So it's 0 is the answer. We haven't minted anything, but we can mint one. Boom. Now we minted one. And then if we look who's the owner of token 0, it's going to be us. You know, token 1 isn't minted, so we get exception, but token 0 works. So what if we do this new thing that we care about, the token URI of token 0? We get nothing because we haven't implemented the logic there yet. So that's a thing we're gonna do. Let's first figure out what we're gonna return here. We need to figure out the JSON, and we need to figure out the image. So let's create a new folder here. So I'm gonna create a new folder. We can call it assets. And then I'm gonna quit here. And I'm just gonna copy from the downloads those, how do I call it? Beaver NFTs. No, PNG. To the assets folder. So here I'm just using the mask, so whatever goes 0 to 3, and copy them all to assets. Now if we look at assets, we have all these images here. Perfect, that's good. What we don't have is the JSON files, right? So let's create that. Let's call it the same way. Beaver NFT 0, but instead of PNG, it's going to be JSON. Boom. And then, you know, what we can do is just use whatever they have, because they are adhering to the same standard that we're trying to. We're just gonna kind of close it, make it simpler. Boom. We don't need that. Cool. So this is for the token 0. And this is what? This is Beaver NFT 0. We can back. For the description, we can just say whatever, Beaver NFTs. Great. Image, that's a thing we're going to talk about later. So let's just put to do here. An external URL. This can point to like whatever website. If it's a game that this NFT belongs to, it could point to that game thingy. Your website. If it's, you know, just for now, we can just we can just point it to where the code lives for this thing. Like, doesn't matter. Is this how did I call it? Yep, perfect. So you can just point it here. Yes, like this. So this is pretty cool. Yeah, also we can add some attributes, so like hard working 100, and then maybe, you know, another trait. Efficient. And let's add a value of 20. So like so. Whoop. Cool. This looks pretty good. But we still don't have the image, right? So there is many ways you can do this. The thing is that you need some place where you go and fetch these resources. You fetch somewhere that is JSON, and you need to fetch the image. When we look at that example before, right? When we went to get this JSON, we went to this API Bang Bangs Club, right? This is a centralized server, probably, that they run, the Bastard Gang Punks team. So this is a way you can do it. Just, you know, host it on your server, point a regular HTTP URL there, and it's going to work. And this is how many people do it. What you can, but notice one more thing. When we find the image, okay, lost it. Here we go. Here we go. Look at that. If we look at the image itself, it's hosted on IPFS, and then this thing. What is IPFS? This is a discussion for another video, I think, but in short, IPFS is Interplanetary File System, and the idea is that it's going to be used across different planets, like on the Mars and stuff. And how this works, it's more peer-to-peer network, so it's very decentralized storage of different types of files. So it's kind of encouraged to use decentralized storage for files when you're dealing with this in this Web3 decentralized, you know, technology place. So it's very good idea to upload it there. Like one way you could do that, there's this library NFT storage. Which is pretty cool. Hope this is it. Basically, they have a JavaScript library that lets you upload these images. Yes, this is it. Uploads these images. You would just follow these steps, and you're good to go. That works. But the one thing to note is that you don't get to change that stuff later, which is really good for the images, you know, and for the thing that you wanna sell NFT. And the expectation is that it never changes in the future. But if you're doing a game, maybe you might, you know, upgrade those NFTs. Maybe you want to support some new attribute or something. Also notice what they've done here. Because you can choose and upload both of the JSON itself and then the image, both on IPFS, and both the links will be in IPFS. But notice what they've done. They put the JSON in their centralized server, and then the image itself is on IPFS. So they still have an ability to change this JSON whenever they want in the future. They can add a new traits. They can even change which image it points to, right? So this is kind of a hybrid solution. So you can do that. Or you can just go all in centralized. Like both the image and the JSON is stored centrally. This is what we're gonna do, just because it's easy. Because one way you can do this is if we just use GitHub. Because this is an open repo, and in general, when you write smart contracts, you're probably gonna have an open repo, because when you upload it to the blockchain, people can decode it anyway. So why not make it easier? So we're just gonna all the data, assets maybe, and push it to the internet. Now, if we look back to, I closed it. If we look back to GitHub and this Beaver NFT thingy, boom. There's this assets folder now, right? And if we look at, well, this image, you know, we have this image. If you click this download button, this is the URL where GitHub hosts all these images for us. So we can just use that. You know, again, this is GitHub doing it. They can change this URL in the future. And then your NFT would stop working. So for like real production stuff, you wouldn't use GitHub probably. Or you would keep an ability to change that somehow in your smart contract. So this is the first bit. No, but actually, let's take this. So this is the image URL we're going to use. Notice that it says, you know, row, GitHub content, whatever. Then there's the project. Then there is a branch. And then there's the path. And it's assets, Beaver NFT, 0 PNG. So then, you know, we can kind of guess that for the next image, it's just going to be 1, right? And so on. So let's take this. This is the URL we want. And if we go back in our JSON, this is the image URL that we wanted here. I hope that's clear, but I did run pretty fast. So, you know, if it's not clear, please let me know. But all right, so let's copy this image, this JSON, and just paste it several times. Boom, boom, boom. And this is gonna be 1. This is gonna be 2. And this is gonna be 3. Like again, if you would be doing this properly, like do I just done 4, right? If you would do generative art, like thousands, you would have a script to do something like this. And then here, we're just gonna fix these zeros to 1s. And maybe let's give it a different efficiency or something. And then here, I just pressed Ctrl D, which marks all the places where this is, which change here, here, and here, which is what we wanted. And then the final one, 3. Perfect. Let's again commit this and push it, because we want to use the GitHub to host our JSONs as well, not just the images. So now it's pushed. So that means that if we, look at JSON here, we get that JSON, right? And that JSON points to that image, which is exactly what we want. So this is the structure that the bastard punks used as well, right? You called something on the smart contract, you get URL for this JSON, and then the JSON itself had an image URL that you would use to reference to the image. So we're basically done there. Then just the very last part that remains is to kind of return it from our smart contract. So let's do that. Yes, so how the default implementation here works is that you can use a base URL here, and then it will add the string ID at the end. This works if you're like building your own server, but we need the ID 0.json, so we're gonna build our own. So you can just take this function, and we're gonna overwrite it in our smart contract right here. So we're gonna do this. It doesn't need to be virtual anymore. Now we can keep that part. All right, so what's the thing? Let's drop this, it's not important. Let's drop this as well. Let's not complicate things. So token URI for this ID, what we should return. Well, basically we should return is this URL, right? So how do we do that? So we should just like return this string. However, there's the ID right here. So you want to concatenate that. Okay, so from JavaScript, what you would do, you would just do this, right, and plus token ID. So this is fine. The problem with this is that this is not JavaScript. This is Solidity, and Solidity is more C than JavaScript. It's much lower level, so it doesn't have concatenate like this, and especially not like this, but it doesn't have concatenate in general. So you can't concat strings just like that. That's not how it works. Because you are actually here dealing with the memory allocated and the bytes, and you're composing them together, and that's not what you're doing here. What you would do is call this ABI encode packed. So and then you put all these parameters here. Boom. And boom. Back. Good. So this ABI encode pact is the way to interact with the memory actually, and we're gonna say take these memory strings and put them next to each other in the memory. So then you have a memory where all these bytes are together, right? So it's gonna take each letter, put it in the memory space, and then it takes each letter of token ID, puts it right behind it, and then takes these few letters and put it at the end. And then just last thing we want to do is just call this to string, cast it to string, because there was still a memory, byte array basically. And now when we say this is a string, we will be able to return this. So let's give it a try. Actually, it's going to be easier than me talking about it. So we can do truffle develop. Nice stuff. Okay, right, we need let's do let contract equals beaver NFT deployed. Boom. Oh, and we need to wait that. And then I guess I don't know if it deployed it. Let's deploy it just to be sure that we got the latest version. So we're gonna do that, then we need to get the latest deployed again. Good. And then we're gonna mint one. Perfect. And then we're gonna get the token URI. This is exciting. Oh, so this is kind of messed up, right? This is not the URL we wanted. There's a bunch of x0000s. So the reason is that we're using this token ID, which is, unassigned integer 256 bits, bytes, I guess, bits. It's probably bits. Wide. No, it's gonna be bytes. Come on. I don't know. And it's so many, places in the memory. So then, if you're like encoding it, put it in the memory, it's going to take that much space. So this is like a hex representation of that number. Luckily, there's a utility library that you can use. It's in the OpenSea suite. So if we look, there's this utils. No, wait. In OpenSea I said there's this utils, and it's called strings here. Okay. So I'm just gonna copy path to it and go back to here, and we're gonna import that thing. Yes. And then just delete the extra stuff. And here we go. So it's OpenSea contracts util strings. That's all we wanted. And then semicolon. And as strings, we could look at the implementation, but there's a strings.toString, which converts uint to a string. So that's kind of what we wanted. So we're just going to use that, and then we're going to redeploy the contract. Okay. What does it say? Oh, okay. So it doesn't have to be view. It can be pure. What does pure mean versus view? Pure means that it doesn't interact with the contract's data at all. We're just using the input parameters and return something, right? And it's all hard-coded. And what you could do is just store this in sort of internal field and then have a owner-only ability to change that, but we don't need to worry about that. But that was just a warning, I guess, so we can still use it. So this new contract we can mint again, because we just got a fresh contract. It has nothing minted yet. And then we can do token URI of 0. Oh, didn't work. Or maybe it didn't compile. Okay, let's try one more time. Maybe let's try this. Yeah, sorry. We need to do that. Okay, let's, to be sure, let's take this one, which was just deployed, and then do contract equals await beaver NFTs at this address, and then token URI and 1. Boom! Perfect, right? So, we don't need to wait for it to be minted, and it kind of works, but let's try. So we got this URL, and if we open that in a browser, like so, we actually get the JSON back. Perfect. So we're in really good state here. What we can do now is just take this contract, deploy it on Rinkaby types network, and we're gonna do reset because I've deployed some before. And then when we get the address of this new contract, we just gonna try and hook it up to OpenSea and see if OpenSea will actually fetch the data, the image and all the metadata that we just created. So this is the climax of this video, if that's gonna work. Sadly enough, this actually takes a little bit of time. And we also need to mint it, which I haven't done. So let's do that first. So it's still doing it. Well, and then I think I talked about it last time. The reason why this takes a little bit of time is that we're interacting with the real blockchain now. So there are real miners mining these transactions and then trying to put it on a blockchain. Right, now it's doing the NFT contract. Let's wait a little bit. And then in the console, what we could do is mint it when we get the address. And we can also look it up on the Etherscan. So this is, we already have the address here. So if we go here, this is Etherscan, right? We can switch to Rinkaby testnet. I'm gonna close the stuff here to make it cleaner. And then look at that. We already have this contract deployed, 30 seconds ago. There's no other interactions, so we haven't minted yet, but let's do that. Console. Network Rinkaby. Boom. Exciting. And then, what we're gonna do is just tract wait beaver NFT at that address. And then contract, boom, mint, boom. I bet it's gonna work. Sorry, I'm just kind of excited. Cool, this worked. Let's do one more. So we have 2 items. In the meantime, if we look at here, the Etherscan, we should see some transactions, right, that we called mint, and it was 10 seconds ago. We should see the second mint in a little while. it went through. It did go through. So, well, I'm sure you're gonna see it in a bit. In the meantime, let's keep that on the right side here. Boom. Let's open it here. Well, yeah, no. Okay. And then we can do OpenSea get listed, I think. So this is what we did last time. It's basically OpenSea is running on testnet as well on Ringcabby, and you can go there and just hook it up to your contract like so. And then it will recognize this contract, Beaver NFT version 4.4. I've tried this a few times, as you can see, and then we can look at items. It is found. Okay. Well, it looks like that's weird. Looks like it haven't refetched it correctly. So let's give it a little bit more time. How do I call Beaver NFT? Yes. They are running some indexing job, right? That goes through blockchain and looks up all these things. It might take a little while before you get your items here. Last time it worked like instantly, but I guess, right? It says 2 items, but no items to display, so it's slowly getting in there. Oh, here we go. So here are awesome Beaver NFT. Here's the image, you know, levels. Oh, cool. So I guess because it recognized that these are numbers, it matched them as levels. So he's efficient at 20, hardworking at 100. And that's, you know, that's where our properties or attributes or traits came from. And here you can see, you know, this is this token, this is a token ID, this is the contract address. It's all here. It's all here. And then there is this other guy. Well, this is pretty amazing, I think. Anyway, as last time what we saw, if you connect your MetaMask, it should recognize that I'm the owner. And I can sell it, right? But this is a test network, so it doesn't really matter, but you could do that. Well, yeah, I think this is it. I think that's all that I had for today. So if you have questions, please let me know. There are a bunch of ways you can do that, even right now. But if you don't, then, well, thank you for bearing with me and, you know, making some beavers. That's really fun. Okay, bye.